In this video, I'm going to show how to use Gauss-Jordan Elimination to simplify an augmented matrix to put it into reduced row echelon form, thereby finding the values of x, y, and z in a system of equations with 3 equations. So since these problems take so long to solve, I've pre-solved it, but I'm still going to walk through all the steps and kind of make sure they all make sense. So first, you need to make an augmented matrix. So you take all the constants, all the numbers, -3, 1, 6, 2, 2, -5, 4, -5, and 2. Then you need to draw a dotted line. That's everything on the left side of the equal sign. Then you need to draw a dotted line, a vertical dotted line, and then you put what those expressions are equal to, so 15, 9, and -3. And then you need to start doing row operations to simplify the entire matrix into row echelon form and eventually reduced row echelon form to find the values of x, y, and z. So first, you take row 1, add row 3. The addition is right here, so you get 1, -4, 8, and 12. So you write your new matrix, 1, -4, 8, 12, 2, 2, -5, 9, 4, -5, 2, and -3. And then you multiply -2 by row 1, and then you add that to row 2 to produce 0, 10, -21, and -15. So then you modify your whole matrix, so it's 1, -4, 8, 12, 0, 10, -21, -15, and 4, -5, 2, and -3. And also one thing to keep in mind when you're doing these row operations, you can modify a row just for the one operation to change a different row. Say you're adding it, so in the case of the first addition, row 1 plus row 3, I ended up changing row 1, but row 3 stayed the same. So you don't have to change both rows based off of just one operation. So then after you get this matrix, you multiply row 1 by -4 and you add row 3. So that produces 0, 11, -30, and -51. And that goes into this new matrix, so 1, -4, 8, 12, 0, 10, -21, -15, and then the third row is 0, 11, -30, and -51. Next, you multiply row 2 by -1, and then you add row 3 to it, so that gives you 0, 1, -9, -36. So your new matrix is 1, -4, 8, 12, 0, 1, -9, -36, and 0, 11, -30, and -51. And another thing to keep in mind is with these matrices, you're trying to get the first term in the top row, 1, and then the rest zeros. Then in the second row, you're trying to get the first and third term equal to 0, second term equal to 1, and the third row, first 2 equal to 0, and the third one equal to 1. So you'll end up getting kind of a compartment of zeros right there, and also right there. So if you have everything but 0, so if you have all zeros here, then that's row echelon form, but if you have zeros everywhere but these ones, then that's reduced row echelon form. So once you go through all these operations, you eventually come up with, I'm going to skip down to this matrix right here for the sake of time, 1, 0, -28, 0, 1, -9, and 0, 0, 1, and then that equals -132, -36, and 5. So now you just do a few more operations on these matrices, and eventually you end up with 1, 0, 0, 8, 0, 1, 0, 9, 0, 0, 1, 5. So that means that x is equal to 8, y is equal to 9, and z is equal to 5. So your solution will actually look like this, and then you can check your work right here, and it in fact does add up. So that is how you solve a matrix using Gauss-Jordan elimination.